So in 2.7, we started looking at ways to combine two functions together. We looked at adding functions together, subtracting functions, multiplying functions, and dividing functions. Those were called the arithmetic combinations of functions. So we want to continue looking at yet one more way to combine functions. This is actually a more unusual way. This one's called functional composition. Functional composition. So here's the idea. You have two functions, f and g. F and g, red function and a blue function. And x is in the domain of g, and g of x is in the domain of f. Let me draw this out. So here's the idea. Okay, you have a function g here. It's like a machine that you plug stuff in, and you have another function f over here. You plug stuff in. The idea is that x can be plugged in to g. Now what comes out the other side of g? G of x, right? G of x comes out. Now we're also told that g of x gets plugged into f, right? G of x gets plugged into f. What comes out the other side? Well, f of, what was the input? G of x. F of g of x is the output. Okay. That's our setup. So suppose f and g are functions with x in the domain of g, g of x in the domain of f. The composition, this is what we're defining here. Let me highlight that in yellow. The composition of f with g is written f-o-g, f circle g. So that's a circle right there. That's a big old circle. It looks like fog. So f composed with g is the way you read that. F circle g, f composed with g is defined as follows. F composed with g. So the idea is you plug in x, right? X comes out the other side as f of g of x. That's the output. So the input is x, right? And out the other side comes f of g of x. Yeah, I'll just erase those arrows. So imagine we had some function called the fog function. Come on, fog, where are you? There you are, green. F circle g. F circle g, f composed with g. So the idea then is that you plug in x into the machine, and out the other side comes f and g of x. Yeah, so going through fog, going through f circle g, going through f composed with g would be exactly the same as x going into g and then g of x going into f and coming out as f of g of x. The same difference, right? It going into f circle g. Okay, so that's the idea behind it. So let's see. Let's do an exercise here. Exercise. Let's say we got f of x is my function. What's my function going to be? X plus 273. And g of x is going to be my second function. Let's make g of x 5/9. X minus 32. So I'm going to call the first dude red. The second dude is going to be a blue. And we're going to evaluate the following. Number one, we want to evaluate, how about we evaluate f plus g of 212. So our input is 212. F circle, that should be a circle there. I don't know why it's a plus. F circle g of 212. All right, so how does this work? So you got a red function. So you're going to write red f first. So the function first was f, so we're going to leave f on the outside. And then g comes second, so that's going to go on the inside. G of, and then you have 212. 212 is the input. Now the idea here is, I am going to totally leave f alone for now. I'll leave F alone right now. I'm going to work on G of 212. What's G of 212? Well, I'm going to plug 212 into the G function. So I'm going to have 5/9 blank minus 32. So here I go. In place of my green X right here, right? My green X, I'm putting 212. Now I'm going to leave my red F alone. I haven't applied my F yet. I got to simplify this blue stuff inside. So I'm going to do order of operations. I'm going to do what's inside parentheses first. Take 212 minus 32. What's 212 minus 32? It should be 180. All right. Now I'm going to leave the F alone still. I haven't applied my F yet. I got to work on simplifying this blue stuff inside. What is 5/9 times 180? Well, you do a little trick here, right? You can do 5, and you can do what? 180 over 9. Just do a little bit of algebra trick there. So the 9 was on bottom. We just took it underneath the 180, right? So that turns out to be, what, 5 times... What's 180 divided by 920, right? 5 times 20 is 100. So we actually got here F of 100. Now, what was the F function? Let's go back. The F function was X plus 273. So that means I'm going to plug in. I got a blank plus 273. Here my X is 100 this time. My input, I should say, is 100. What's 100 plus 273? It's 373. There we are. Okay, so let's follow this through. We had 200. 200 got plugged into the G function. We plugged 212. 212, not 200. 212 got plugged into the G function. When we plugged 212 in, it simplified down to 100, and then we plug 100 into the F function. Where was the F function? It was up here. We got 100 plus 273, gave us 373. Okay, let's do another one. 2. Let's say I got F composed with G of 32. Right? 32. All right, red function is F. Come on, red. Blue function is G. The input is 32. So here I'm going to write this is equal to, you start with your function on the left, F of, and then you put your second function, G of, and then you put your input, 32. Now you leave your outside function alone, in this case, which is the red F, and you work on simplifying your inside G of 32. So simplify the blue, G of 32. If you remember the G function, it was 5/9 times X minus 32. That means we're going to have to plug in a 32 in place of X. So we're going to have 5/9 blank minus 32. So what goes in place of this blank right here? In place of that blank right there was the X, 32, right? 32 goes in right there. Now we simplify this, come on. We simplify this a little bit. I have what? F. Leave the F alone. Leave it on the outside. Work on the inside. Work on simplifying the blue inside. We're going to have what? 5/9. And remember, you do what's in parentheses. 32 minus 32 is 0, right? So we have F of, simplify the blue, 5/9 times 0. 5/9 times 0 inside there is 0. All right, so we simplified the blue. So now we have F of 0. How do we find what F of 0 is? We got to take 0, which is your blue input, and that's going to get plugged into the F function, which is X plus 273. So we're going to have a blank plus 273. That's what we have to calculate. Blank plus 273. In place of that blank right there, I'm going to put my input, which is 0, right? 0. So 0 plus 273 is 0. I'm sorry, 273. 273. 0 plus 273 is 273. All right, let's just do this in general. What would, for example, number 3, F circle G of X be? This time no numbers, right? No numbers getting plugged in, just an X. Well, I got my red F function. I have my blue G function. That's supposed to be blue right there. Now it's blue. And I have my green input X. Well, this is defined, F composed with G of X is defined to be F of blue G of green X. Now, we want to leave the outside function alone, the red function alone. What's G of X? G of X, we can't plug in any numbers, but we know G of X is defined to be 5/9 X minus 32. 5/9. Parentheses, blank minus 32. Let's just fill in the green X there. Now, really can't simplify that too much. So that's going to be our new input. It's going to be our blue input, what I just underlined here in blue. So now you plug that blue dude into your F function, blank plus 273. So you're going to have a blank plus 273. And in place of the X, right here we had an X, right? You're going to put the whole blue dude, 5/9 X minus 32. That'll become your input. All right, so there we are. This is F composed with G at X. Yeah, so when you don't actually have a number that's being input, when you have an X instead, notice we have an X rather than a number, you expect your expression to not just be a number, but to actually have an X. Okay, so that's a little composition of function right there. So maybe you would have noticed what was happening here with these numbers. Pay attention, right? When 212 was input here, 212 got converted to, notice, 100. And then 100 got converted to, well, it'd be nice if this were to erase. 373. There it goes, 373. In the second case, when we had 32, 32 got converted to 0. And then 0 got converted to 273. So it turns out that what's going on? Come on, it's not erasing. Erase, erase, please. Thank you. There it goes. This is scrolling now. So you got these two functions, right? You got your blue function. Come on. Your blue function. Your red function. It's not red. So you're taking an input, like 212, right? It's getting converted to, for example, what was it converted to? 100. And then that got converted to 373. We had a number 32, right? That got converted to what? A 0. And that got converted to what? 273. So, maybe you notice what's happening here. Here we have Fahrenheit, degrees. Fahrenheit. Here we have Celsius degrees. And over here on the far right, we have what are called Kelvin degrees. So anyone with any background in like a basic chemistry class would have seen this before. So the first function converts from Fahrenheit to Celsius. The second function, the F function, converts from Celsius to Kelvin. And your F circle G function, I'll put this one in purple. F circle G, you can imagine an F circle G function. That's the function we've been dealing with. That takes the Fahrenheit and converts them directly to Kelvin. That's what we've actually been doing. From, for example, Fahrenheit to Kelvin. So this last formula, F circle G of X, that takes you directly, this is the general formula right here. So here the input here in purple would be your Fahrenheit, and the total output here would be Kelvin. Yep, Kelvin. All right, let's do another quick example. Exercise. Let f of x be 2x squared minus 1 and g of x equal 3x squared plus x to the fourth. Evaluate the following. 1. G circle f of x. 2. F circle G of x. Well, we'll do that one later. Let's just focus on G circle F. So I have what here? G, oh crap. So let's call G my blue. Let's call F my red. This time the F is to the right and the G is to the left. So this time the G is going to be the first function. So we're going to write what? G of, in parentheses, F of, in parentheses, X. So your first function is G, so you're going to leave that one alone this time. And inside you're going to put the F of X. What's the F of X? Focusing on that. F of X is simply what? 2x squared minus 1. I'll make the X green. So 2x squared minus 1, what do we do with that? Well, we plug it into the G function. So we're going to have what? 3 blank squared plus blank to the fourth power. And in place of those blanks, rather than putting x, right, rather than putting an x, I'm going to put my input, which is now 2x squared minus 1. 2x squared minus 1. 2x squared minus 1. Do we want to simplify that? We do not want to simplify that. Please do not simplify this. It is absolute torture trying to FOIL these out and simplify them. It's not torture, but it's tedious. Let me just say it's very tedious. Okay. Now let's do the other. Let's do F circle G of X. This will be our last example. F circle G of X. So this time we got the red one first, and we have the blue one second. So what we're going to write is F first, of, and then in parentheses, G of, and then in parentheses, green X. Now, because the red is first and on the outside, we're going to leave it alone for now. And we're going to focus on the G of X in blue. Remember what G of X was? The G function here was what? 3x squared plus x to the fourth. So I'm going to put in place there 3x squared plus x to the fourth in the parentheses. Now, there's really nothing to do there. I'll make the x's green if you like. There's really nothing to simplify there. So what we're going to do, we're going to take this blue dude, 3x squared plus x to the fourth, and we're going to plug it into the red function, 2x squared minus 1. So we're going to have a 2 blank squared minus 1. Let's do that. Come on now. 2 . blank squared minus 1, right? This is the red function. Now, what are we going to do? In place of the blank, we're going to put our input, which is now 3x squared plus x to the 4th. And we don't want to really FOIL this out. We don't want to simplify that. That is a little tedious to do, so we'll just leave it like that. Now let's compare this f of g of x expression to our expression for g of f of x. Notice that these two things are very different. See the blue box and the red box, they're very different. Yes. So f of g of x and g of f of x are usually going to be very different animals.